a sex difference in this. Females actually are the ones with the greater sense of taste, with Judy Goulden here, than males, whether in fact it's taste or smell. And that's why the genes for these receptors are apparently on the X chromosome. And why should they be? Well, the answer to that again seems to be to protect the woman, in this case, from administering poisons to her baby. So to actually protect, because the baby is much more sensitive to poisons than, of course, the adult is. And recent theories are that, for example, morning sickness is associated with, if you have it, it's associated with a lower risk of miscarriage. And it's now thought, for example, that morning sickness may be a generalized food aversion to both vegetables, it's not just meats, and meats, which are likely to contain low levels of toxins. And it happens at a particular point of pregnancy when the baby's organs are growing, which is when they're most sensitive to toxic damage. It's a theory still, but may explain it, may even make some people feel better. Perhaps not. Some mammals are undoubtedly more sensitive to taste than we are. And the rabbit, for example, has, on its small tongue, 17,000 taste receptors, pigs 15,000. Our total is about 9,000. But the thing is that really this sense is probably still the least well understood. And so we can't really tell too much about the different capabilities of other species compared to ourselves, except that there's no clear basis for any assumption that we are the superstars of the taste world. In fact, quite the opposite. What about smell? Well, yeah, we all know that particularly dogs are much more dependent on this sense than we are. But there are actually two different detection systems, and they may have evolved completely separately in the brains of mammals. The first of these, the most primitive one, is actually a system for detecting what are called pheromones, chemical messengers. And they are dissolved in liquids. They are born in liquids, carried in liquids, such as the urine, saliva, and glandular secretions. And they're detected while they're still in this liquid form. The other one that we are far more familiar with is smells or chemicals that are actually carried in the air, airborne odours. Both systems are remarkable in that they have huge numbers of receptors, and that explains in many ways why less of the brain has to be dedicated to analysing smells, because a lot of the processing is actually done in the nose, in the receptors, before it ever gets to the brain. Unlike the visual system, which only has a couple of receptors at the end of the day, and it has to do all the computation in the brain, so it has to dedicate a lot more space to that task. All of this, though, allows